some, air quality standards. What do we consider the amount of these particular pollutants that could be found in the earth? What concentrations, could be found in the atmosphere? What are the safe limits of the concentrations, I should say. So some of the pollutants listed here, for example, are carbon monoxide, nitrogen dioxide, ozone, lead, particulates, and sulfur dioxide. You'll notice that the concentrations are given in units of parts per million for everything except for lead and particulates, and then in units of micrograms per cubic meter for everything. The reason why lead and particulates are not given in units of parts per million is because parts per million are assuming the parts are all in the same state, that state being the gas state. As it turns out, lead exists in the air as little bits of solid, and particulates are other undefined bits of solids such as dust, pollen, viruses, anything else. Okay, so we're going to come back again and today and start taking a closer look at, so we know there's things called mixtures, and we know that they're made of certain substances. We want to be able to understand, what are those substances? Okay, so back to our organizational chart of matter. Last time we spent our time talking about mixtures. This time in part one of this lecture, we're going to be talking about elements and compounds, these pure substances. Okay, what do we mean when we say element? What do we mean by compound? How do we define them? How do we know, how to name them and what their names mean? All right, so that's what we're going to be doing today. First of all, the pure substances box was separated into something called a compounds and something called elements. So the definition of an element is it's a substance that cannot be broken down into simpler substances. All right, so fundamentally it's all the same type of atom that makes up an element, and chemically you cannot break it down into a simpler substance. All right. As it turns out, most elements that exist in nature are metals, and most elements are found as solids. All right. Further, most elements, as they exist in nature, can exist stably as single atoms, as just atoms. But there are 7 common elements that are never found as single atoms in nature. They're all found as diatomic molecules, and we're going to have to memorize them. But first of all, what I mean by a single atom, for example, helium. The element helium can exist in nature as a single atom all by itself, as a stable substance. However, oxygen and nitrogen cannot exist as a single atom. Rather, they exist as what we call diatomic molecules, 2 atoms chemically combined. All right, so oxygen in nature, when we find it, for example, in the air, it's going to exist as the diatomic molecule O2. All right, and nitrogen is going to exist as the diatomic molecule N2, whereas helium just exists as an atom. So that's what we mean by a diatomic molecule. All right. Let's see. And I mentioned that there are 7. Here's a periodic table. The 7 elements that exist in nature as diatomic molecules. You have to memorize it. There's not a lot in this class that you have to memorize, but this you sort of do. And I'll tell you, there's an easy way. The 7 elements that exist in nature as diatomics are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Okay? And the way I remember it is I know there's 7. I find atomic number 7 on the periodic table, and I make the number 7, and that covers 6 of my 7. The other one is hydrogen. It's kind of weird. It's an outlier, but you just need to memorize hydrogen also. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine all exist as diatomic molecules in nature. So when we write them, for example, later on we're going to be looking at chemical reactions, we always have to write them as they exist. So oxygen, O2, nitrogen into fluorine, chlorine, bromine, iodine, and of course hydrogen. Those are the 7. All other elements can exist as single atoms in nature.